All right. Hello. Good afternoon, everyone. Hopefully you all had a nice and relaxing long weekend and you're ready to do some mathematics. So welcome. Let's give a few more minutes just to kind of get everybody in here. And welcome to our next installment of Math Monday. Goodness gracious, we don't have much left in the semester, eh? Like maybe 3 weeks. That's about it. We have like what, maybe four or five more classes together, and then we're done. We are getting pretty close to the end of the course. So there are a couple of kind of final dates to keep in mind. So this is the housekeeping stuff to get it onto your radar. Next week on Wednesday, the final assignment is due. So next week by Wednesday, the final assignment is due. And then our last test together will be on November the 29th. So 2 weeks from today will be the final test. I still owe you like a little practice quiz, so I will get that hopefully up to you. This week it's on my list of things to do, as well as mark your third assignment. I haven't started marking your third assignment, unfortunately. I know, me too, Megan. I had a big push before the weekend here. So yeah, I was a little burnt out over the weekend, but yeah, I'm feeling pretty good about this week. I should be able to get lots of marking done for you guys so that we can kind of glide into the kind of final stretch here. So Laurel's asking, is our final exam on campus or from home? It will be from home. It is organized at the same date and time as all of the other Math 114 face-to-face classes. So all of us are scheduled together because we don't know if you have some face-to-face classes in your schedule. So we tried to schedule all of the 114 exams together to prevent any exam conflicts. So if you do have a conflict with the date and time, you need to take that to the registrar to get the paperwork. And since my class is the online section, I probably am going to be the one that has to make arrangements for you. Yeah. Well, make sure you go have a little tour of the campus and know where you're going before your final exam date, or at least arrive there a little bit earlier. So you have that ready to go. But yes, our final will be similar to the test format. It will be done face-to-face, and I'll be available during that 3-hour time period in case you do have any questions or concerns along the way. And it will be similar to all the other tests. I'll give you an exam template you can write on. You can upload that to the Dropbox. And then I'll be using the exam template as I mark through each final exam one by one. So today we have, I would consider it kind of a nice little condensed topic. It's a nice way, I think, to come back from a long weekend. We're going to talk about perpetuities today. And let's just start by defining what a perpetuity is. A perpetuity is an annuity that has payments that continue on indefinitely. And so that means we basically have kind of two, well, I mean, we could break it down into 4 if we wanted to, but we have essentially 2 main types of perpetuities to deal with. We have the ordinary style perpetuity, and we have the perpetuity due, which I think is my favorite to say out loud. So it really just depends on when the payments happen. So I want to essentially develop the formulas for you, kind of give you an understanding of where they come from. We'll do a couple examples. This is going to be, I like this topic. They tend to be very nice and easy questions to work with. So a nice relaxing class today, nothing super intense. So we have 2 main types. We have a type in which the payment may happen at the end of the pay period. So if the payment happens at end, We will call this an ordinary perpetuity. And of course, if payments happen at the beginning of the payment period, this is going to be a perpetuity due. It's an annuity due kind of problem, only we have perpetual payments. Okay, so this will be the terminology I'll try to use when discussing the examples we're going to work with. So maybe let's look at a time diagram. So you can get an idea of what this is going to look like in practice. And then I'll show you essentially where we find that formula, how we end up with the formula for especially the ordinary case here. So I'm just going to grab a ruler here. And let's mark out today's date. And then I don't know exactly when the payments are going to happen. So I'm just going to mark out a couple of marks like this. And then put some dots because this will happen indefinitely. This will happen perpetually throughout essentially the rest of our lives or the rest of our investment. And in the ordinary case, payments happen at the end of the time period. So our first payment would happen right here. This is going to be at the end of the first time period. And we have a payment structure that looks something like this. And those payments keep happening at the end of every pay period. Yeah, and to infinity and beyond. Yeah, if you want to quote Toy Story, exactly. So these payments happen in perpetuity. This is, I believe, where that phrase comes from. And so what we're typically interested in doing is we're interested in determining the fair market value today of this stream of payments. So think about it in the following way. We go into the bank, we make some kind of deposit into the bank, and then every month for the rest of our lives, the bank will give us some kind of equal payment, for instance, if it's a monthly kind of perpetuity. And this continues on till the end of time, essentially. And so what we want to do is we want to collect all of these payments, and we want to bring that back to here. And we want to develop a formula to calculate the principal amount. Notice that it doesn't really make sense to talk about the future value of a perpetuity. Do you have any reason why that might be the case? Why do you think it does not make sense to talk about the future value? Yeah, so that's one way to easily think about it. So it's an infinite kind of payment stream. So yeah, we never really know when the end date's going to be. So it's going to be really hard for us to talk about what n is, for example, in our future value formula. And yeah, we can't really ever get there or get to that endpoint. So it doesn't really make sense to talk about the future value. The future value is technically infinity dollars, and whatever that means. I mean, I wish I had infinity dollars. But I don't. So that's why we're really only interested in calculating the principal amount of a perpetuity. So let's take a look at how we do that. So we have a formula. This is the principal amount formula for an ordinary annuity. So here's an ordinary simple annuity p-value. And what we're going to do is we're going to allow n to get really, really big. And this second piece right here, this piece that I'm going to highlight, has a power of negative n in it. So if you remember from working with exponents, we can think about this as 1 over 1 plus I to the power of positive n. And as n gets really, really big, because down here in the denominator, because we have a number that's bigger than 1, so all of this down here is larger than 1, all of this fraction is going to have a really, really big denominator as we allow the number of payments to get bigger and bigger. And because this denominator gets big, we're going to end up with really, really small decimal numbers. And in fact, with the calculus kind of argument, which I don't know how many of you know, but as n tends towards infinity, this fraction tends towards 0. And what we end up getting is the formula for an ordinary perpetuity, and it looks something like this. So you will notice that on your formula sheet under the ordinary annuity section. It will say something like maybe like ordinary perpetuity or like P perp or something like that. It should be on your formula sheet. And it's really just as simple as taking the payment size and dividing by the periodic frequency I. That's because n tends towards infinity, so we don't have to deal with this 1 plus I to the negative n term. It kind of disappears and goes away. So this is our formula for an ordinary perpetuity. Bada boom. Now let's take a look at the time diagram for the other case, which would be a perpetuity due. Can you make that I more clear? It looks like a funny symbol. Yeah, sure. Hey, no worries. Yeah, so that should be an I in the denominator. Okay, a little I. This is our periodic interest rate. So let's do this one more time. Let's just consider what the time diagram is going to look like for the annuities due case. And we should be able to kind of develop a formula to help us through this one as well. So the setup's going to be very similar. We have our time diagram divided up into our payment periods. The only difference is in the due case, we have a payment due right away. So our first payment actually happens immediately right now. And all of our corresponding pay periods have the payment happening at the beginning of each of these payment periods. And what I want you to kind of take a look at is I'm just going to zoom out so you can see the structure of the annuity due case. So if we look at the structure, what does the formula do for us? It gathers up all of the payments and drops the fair market value one space kind of before the payment size. So what we're going to do here is be a little sneaky. We're going to kind of use the same formula. We're going to grab all of this. We're going to move that to here. We're going to call it number 1. So I'm going to use the exact same setup as I did before. And then what I'm going to do is I'm going to add that extra payment that we're essentially missing. So what we get here is if we want the fair market value today, we need 1 plus the extra payment that is due immediately. And we know how to calculate 1. 1 comes from the formula that we saw earlier. So PMT over I plus the extra payment. So that's how we deal with the annuity or the perpetuity due case. So that's where the two formulas come from. One corresponds with your ordinary annuities. One corresponds with your annuities due. Maybe you guys can let me know, how do you think these formulas are going to change if we're working with a general kind of annuity? So both of these are for simple cases where the payment frequency and the compound frequency happen to be the same. So what do you think we do in the generalized case? Do you have kind of an intuition about what might be done? Yeah, Alexander, you're absolutely right. So your intuition treats you well today. So the idea with the generalized case, when the frequencies don't line up, we just replace I with I2, and that's how we take care of that problem. So I'm just going to put that in as a note, and then that gives us some time now to dive into some examples. Sorry, I have a conversation going with a student who wasn't able to get into class today. Oh no. Okay, so note. What do I want to say? So note, if you. So if you have the general case, first calculate I2. And then you're going to use your corresponding formula. Okay, how is that for a nice little kind of 15-minute rundown of perpetuities? Do you kind of have a general sense for how those things are set up? Is that helpful? Does that make sense? I know hopefully working with some examples will be helpful. It seems more easy because it technically is. There's less variables to work with. That's why it feels more easy, because n disappears essentially, right? We don't really have to worry about n anymore. The I2 formula is the same as the last class. Yes, exactly. So this I2 that we use, still the same. It's still I2 is equal to 1 plus I1 F1 over F2. So it's still the same one, yeah. It's getting pretty windy out there, my friends. Holy cow. It's like a monsoon right now. By the way, did you guys hear what happened? Like, are any of you like over around like Hope, Princeton? Merritt has been evacuated. Oh my goodness. Yeah, it's getting pretty wild out there, isn't it? I drove through that. I was in Tofino over the weekend, so I had to drive through all of that last night. It was insane. So I'm literally watching a tornado outside my window right now. This is crazy. Okay, so yeah, I ended up well, my partner ended up driving, but yeah, we got to the ferry and across the strait okay, and then we were able to get into, I think, into Chilliwack, and then we had to divert up through Hope. I know, like, what is going on out there?
Poor Jackson. I have a heart attack.
Oh, goodness gracious. Holy cow, yeah. So anyway, I ended up getting diverted kind of north north of the river. What river is that? That's the, geez, I should know it. That's not the Tulameen River, is it? It's the other one. Fraser? Fraser, yeah, thank you. Yeah, so I got diverted kind of north of the Fraser River along Highway 7. And then like as soon as we kind of passed through there and through Hope, then there was a big landslide on Highway 7 that cut off that like kind of last way to get to and from the lower mainland. Seven had another landslide. That's crazy. Yeah, like it's been nuts out there. Like it just was nonstop. When I was on the coast, it was like nonstop rain for like 3 days. So okay, let's see. Can you hear that? Can you hear that through my speakers? I'm just curious if you can hear the rain right now. No, okay. I was like, it is really loud. It is like thunderous out there. Okay, we're gonna pays $5,000 at the end. This should say principal value, not future value. Okay, hopefully that will work. So we're going to determine the principal value of a perpetuity that pays $5,000 at the end of the month for the rest of time, essentially. And we're going to assume interest can earn 5% compounded monthly. That will be part one. And I want to do the same thing, just changing it to compounded weekly. So you can kind of see the difference between these two cases. Yeah, we've ended up passing through Hope. Pretty much everything was closed by then. Like Highway 1 was closed, the Coca Hollow was closed due to all the flooding. So we ended up taking the Hope Princeton Highway, Highway 3, got through Princeton okay, and took kind of 5A up to the connector to get back into Kelowna. I've heard Princeton is now pretty much underwater. Hope lost power like after we yeah, I hear you, Laura. Like I cannot eat. It's so dark outside and windy and rainy. So I've had also been off of like I'm with Rogers too. So I think the connection with the cell phone towers have been having a pretty rough time today as well. Is that lightning? Oh. You don't get to see too many of those in the Okanagan. That's fun. All right, let's get through this pretty quick then, because I have a feeling we might end up losing connection here. So number one, we are going to do a couple things. When I walk into a question like this, I want to figure out what kind of annuity or perpetuity that I am dealing with. We are working with end of month payments, and in part one, we have a compounded monthly structure. So this is an ordinary perpetuity, and this is a simple kind of perpetuity. So there's no need to calculate I2. We just need to go to our formula, grab our formula, which is the payment divided by I. Since it's at the end of the pay period, Alexander, we don't have to add the extra PMT. So we literally just set it up like this. We're going to take our 5,000, we're going to divide by the periodic frequency, which is 5% monthly. And yeah, we're going to just try to find out what this number is. So Alexander is suggesting it's about 1,200,000. So I'm just going to grab my calculator, toss that in, see what we get. Perfect. So I can verify your first answer there, Alexander. It should be 1,200,000. There's another big flash of lightning. Smokers. Okay, moving into our second example. Again, payments are still staying at the end of every month. But now we have a discrepancy in the frequencies. We have the monthly payments, but we have a weekly compounding. So this is now a general kind of case. This is general and ordinary. We're going to calculate I2. Yeah, my apologies if the power does end up going out on us here. I'll try to kind of sneak my way through this example, and hopefully that will give you enough firepower to kind of deal with the different cases. Okay, what is I1 in our example? I1 is the compounding frequency that's given to us, which is 5% weekly. That means F1 is weekly, and F2 is going to be what we want, which is the monthly lineup. We want this to line up with the payment frequency. Okay, it sounds like it's letting up a little bit out there, so that's nice. Okay, can someone verify I2 for me? Oh no, raining ice, that's not good. All right, so I'm just going to wait for someone to be able to verify that I2 calculation. I don't want to jump into doing the last calculation. You see get 0.08. So let me try that one more time. 0.5 weekly to the monthly. So I still get the 4173349, Laurel. So maybe just double check your how you put the power in. So just be careful with that 52/12. You may have to put brackets around that if you're using the business math calculator. After you've calculated I2, you just want to divide your payment size by that decimal number. So in this case, we're going to take our 5,000. We're going to divide by our 0.0041749. And let's just verify Alexander's number here. Yeah, that sounds quite good. Okay, great. That is good, Laurel. So yeah, we got $1,198,078.57. Yeah, so I can verify Alexander's. And Gerline, yeah, this is in general, this is how we do a general style annuity or a general style perpetuity always. We always calculate I2 when working with a general annuity. So there you go. That gives you kind of, I would say, some kind of basic firepower to deal with perpetuities. The only difference when working with a perpetuity due is that the payment happens immediately. So you're going to have to add that extra payment in. You know, I think I'm going to have time to cover a perpetuity due. So let's get one of those set up. And then that's probably going to be it for today. All right, so Okanagan College. Let's do set up anniversary. So The most common place where you will find perpetuities used is in this kind of situation where maybe we want to set up a fund that will pay out students for like something like a bursary. So an institution like the college might say, hey, I'd like to set up this fund. They call up the bank and they say, how much money do I need to deposit in order to ensure that we have this bursary of $700, for example, that we're going to be able to pay out at the beginning of every year. So I would say this is a very common kind of situation where this might happen. So let's work with this. Let's say the bank says, hey, I got an interest rate of 2.75% compounded monthly. How much do I actually need to invest in order to ensure that I get this payment of $700 every year? So as we usually do when we walk into a situation like this, we want to kind of get an idea of what kind of annuity we're working with. So payments are happening at the beginning of the year. My interest rate is compounded monthly. Knowing that, I know that we're in a general perpetuity due kind of situation. Since it's a general perpetuity, I am going to have to calculate I2. So the current interest rate is going to be our I1 and F1. Our current interest rate is 2.75% compounded monthly. We are paying yearly, so that's one time per year. That's going to be our F2. So remember, F2 represents our payment frequency, which is one time per year. So let's go ahead, let's calculate I2. And I get something like 0.0252. So somewhere in this neighborhood. So if you're happy with that value for I2, because this is a perpetuity due, we have that extra payment that we have to take care of. So our formula is the payment plus the payment divided by I2. Our payment sizes are 700, so we can fill that in. And we'll fill in our I2. And then we walk away from class today hoping that every question on the final exam is a perpetuity. Wouldn't that be great? So I get something like $28,360.61. It would be too easy. Yeah, it would be too easy. But you should expect some perpetuities on the next test and on the final exam. I think they're very, I would consider them very nice questions to have on a test. So they're usually like a very easy kind of 3 to 5 marks. So there you go. Hopefully that gives you kind of an idea of the style of question that might get asked here. The idea here is that these payments happen forever. They do not end. And this, if you're kind of curious to know a little bit more, this is the amount of money that I would deposit into the bank at the interest rate of 2.75% monthly, so that at the end of the year, when I go to make my payment, I have $700 of interest that I've made. So this is the smallest amount of money that will ensure that I get at least $700 of interest. So I'm not sure if you know that, but if we were to calculate the future value of this at the given interest rate, let's see what we get. I think I keyed something in wrong. This is monthly. What did I do? Why doesn't this make any sense? It's not 28,360. I was too much. Oh, 380.61. Okay. 28,380. 28,380. Let's see if that makes a difference. Okay, 29. Still not getting what I want. Still not getting what I want. Something doesn't make sense. Compound the monthly. What is the future value of this after one? I got it. Oh no, a different I2. Is my I2 messed up? That could happen. It happens. Oh yeah, I was way off, wasn't I? How does this look, Laurel? Does this look more along the lines of what you got? Okay, great. So let us alter that I2. All right, I get 25,835 and 30 cents. Okay, how does that kind of line up with 28,835, 30? Alexander, I trust you. Okay, so that looks good. So let's try finding the future value of that number. Maybe it will work. All right. I think it's 25,835.30. So I got 26,554.79. Something's still not working here for me. $26,535.30. Yeah, it's super weird. Anyway, what's supposed to be able to happen here is that I'm supposed to be able to actually add this year's worth of interest to my money that I've deposited. Oh. Yeah, something's just not adding up. But anyway, this is supposed to be the amount of money that I deposit, and I allow it to accrue interest over 1 year. And by allowing it to accrue interest, I actually end up earning exactly $700 in interest. So I'm able to pay out this payment of $700. So here it might be something to do with the beginning of the year that I have to think about a little bit more, but it might have something to do with the payments not lining up at the right spot. So I think that might be an error on my side. Kyle, I'm not exactly sure what your question is. You can use I2. Yeah, you should, when you do the future value, you should be able to use either the regular interest rate or I2. You could use either or. You should end up with the same future value because they're equivalent interest rates. But anyway, no, I think there's something else that I just I'm just a little tired and unable to figure it out. So I think that whether or not you use I2 or whether or not you use 0.0275 over 12, you should get the same the same final answer for FV. Okay, so that's all I really want to talk about with regards to perpetuities. You got two different types, one that sits with the ordinary annuities, one that sits with the annuities due. If you have the general case, it's solved the same way as we've been seeing so far, which is to calculate I2 first and then utilize that in your formula. I apologize about the end of class here. I wasn't able to kind of get the future value here to work for you guys, but ideally the principal amount that we get, so these principal amounts that we get are the amounts we would input into the bank at the current interest rate that would guarantee that at the end of the kind of interest accrual time, we have exactly the amount of interest we need to pay our perpetuity. And that's essentially what this value is supposed to represent. So with that said, I'm going to end off class here. I know I got a text from somebody asking me to stick around for a few minutes, so I'll stick around if you have some questions. Looks like our storm has passed through. So hopefully we're all good and we've all survived the one thunderstorm of the year in Kelowna. Weird that it happened in November. Hey, you're welcome, JP, no worries. As always, thank you for tuning in and listening to me rant about mathematics for an hour.
That was me that asked the question, Brian.
Okay, sounds good, Laurel.
Yeah.
So is it something from the textbook or is it, you said from the assignment, right?
It is. I actually wrote myself a couple of questions here. From doing the reading from the additional information that you provided, I couldn't quite answer all of the questions that I had. So I did go looking at other online resources.
Okay.
But one of the things I wanted to make sure is I have made the assumption that the target over rate night compounds daily.
We're going to assume everything compounds monthly. I don't know exactly the compounding structure of the target overnight rate, to be completely honest, but let's assume everything has a monthly compounding rate. Okay.
That would probably explain why I was getting these astronomically large amounts coming out of my calculations.
Yeah,
okay, I did find, like, essentially, because it is what the interest rate they would charge for overnight, my head went to compounding daily. And so then I was trying to,
honestly, that kind of makes sense if that is the case. But I think just to make our calculations easier, let's do monthly.
Okay, let's assume monthly. Okay, it doesn't really matter. It's just all. At the same time, I was trying to learn a little bit about the Bank of Canada stuff because we've dealt with it so much over the years, not directly so much. But anyway, the other thing that I had seen in my reading was that while the Bank of Canada will lend money to businesses, it's usually for a limited time period of 6 months, but it can be renewed at the bank's discretion. So we're just not worrying about that part either.
Yeah, so you're not when you work on this assignment, you are going to be, let's say, a private corporation that is lending out money to
Okay.
your clients.
Okay, and then my third question, I think, got answered in class, and it was based on what we had talked about last class. And that I just want to make sure that when we are calculating I2, we're always doing it in terms of, you want the compounding frequency of the interest rate to be transformed into a new rate at the payment frequency. So basically I2 and F2 are to do with the payment frequency.
Yes, that's exactly correct.
Okay, I just wanted to confirm I was understanding that correctly. I think the biggest problem I was having in the calculations was to do with the compounding daily of the target overnight rate.
Yeah, and the same thing will do the same thing with the prime rates as well. So when you get into that kind of prime rate section, assume that the prime rates are going to be compounded monthly as well.
Okay, all right. I was making it way too hard for myself. Yeah, the numbers were just unbelievable, and I thought this can't be. You can't start with a loan of $10,000 and end up in the hundreds of thousands of dollars in 2 years. I mean, well, you probably could if it was compounded daily like that, but even that I don't think could get that large. So anyway, glad you made it back safely. We went to Tofino for the first time back in September because our son had lived in Tofino for a while. We were going to the island anyway.